Hello everyone. One of the grade 10 math competencies is prove the rational root theorem. I'm not really sure if your teacher will require you to prove this theorem, but at any rate, I will present to you the proof of the theorem. So this is the statement of rational root theorem. Given a polynomial p of x equals a sub n times x to the power of n plus a sub n minus 1 times x to the power of n minus 1 and so on and so forth plus a sub 0. If p of x has a rational root p over q expressed in lowest term, then p is a factor of a sub 0 and q is a factor of a sub n. So don't worry about this notation here. This just means that our polynomial is arranged from the highest degree to the lowest degree, such that the last term is the constant term. So we are going to prove two parts here. The first part is p is a factor of a sub 0, and a sub 0 is actually the constant term. And the second part is q is a factor of a sub n, and a sub n is our leading coefficient. In order for us to prove this theorem, we need Euclid's lemma, which states that for integers a and b, so this notation here means a and b are integers. If p is a prime such that p divides a times b, then p divides a or p divides b. To understand this lemma, we are going to have illustration. It is true that 3 divides 15. So this means it's also true that 3 divides 3 times 15. Okay? By Euclid's lemma, we can say that either 3 divides 3, which is true, or 3 divides 5, which is actually false. Now, this is the proof of the theorem. So the first part, we are going to prove that p is a factor of a sub 0. So our proof starts with the definition of a polynomial function. So the first thing we're going to do is to equate this polynomial function to 0. And then the second step, we are going to evaluate our equation at p over q. Meaning to say, we are going to replace all the x's we have here with p over q. And this is what we get. After that, we are going to multiply all terms by q to the n. So multiplying all the terms we have here by q to the n, this is what we get. Now, among the terms here, it's the last term on this side that has no p. So we are going to move it to the right hand side of our equation. So it now becomes negative a sub 0 q to the n. This one is being moved to the right hand side. Now, if we look at the terms we have here, p is a common letter or variable. So we are going to show that p is a factor of the left-hand side of our equation. So since p is a factor of the left-hand side of the equation, so we can also say that p is also a factor of the right-hand side of our equation. So we can say p divides a sub 0 times negative q to the n. And from Euclid's lemma, okay, p divides a sub 0 or p divides negative q to the n. So we have proven the first part. Now let us start the proof of the second part. So notice here that the first term is the only term we have here that has no q. So we are going to move it to the right hand side of our equation. Now all the terms on the left side have q. So we are going to show that q is a factor of all the terms. Now since q is a factor on the left hand side of the equation, we can also say that q is a factor of the right hand side of the equation. So we can write q divides a sub n times negative p to the power of n. By Euclid's lemma, we can now show that q divides a sub n, or q divides negative p to the power of n. So we have proven the second part. Now, how does this rational root theorem work? So we will have an example. Give the probable rational roots of p of x equals 2x cubed plus 3x squared minus 3x minus 2. Then give the rational roots. So for the probable rational roots, we are going to get the factors of negative 2, and that will be our numerator, and the factors of 2 as our denominator. So picking one factor from the numerator and one factor from the denominator, we have these combinations. And these are the probable rational roots. So there are 6 of them. Now, how do we find the rational roots? So we are going to try these 6 probable rational roots. For example, if we are going to try 1, so we evaluate our polynomial at x equals 1. Okay, substitute all the x's here with 1, so we get 0. And also, if we try negative 2, okay, substitute negative 2 to all the x's we have on our polynomial, so we have this result. It's also 0. And trying negative 1/2, okay, substituting all our x's here with negative 1/2, we also get 0. So this means the rational roots are 1, negative 2, and negative 1/2. Now let's do another example. Give the probable rational roots of p of x equals x to the power 4 plus x squared minus 2, then give the rational roots. Now, probable rational roots, we are going to get the factors of negative 2, that will be our numerator, and of course our denominator will just be 1, the factors of 1, because the coefficient here is just 1. So we have these combinations. And trying 1, okay, evaluating our polynomial at x equals 1, the answer equals 0. And trying negative 1, we also get 0. And if we try 2, it will not give us 0. And if we try negative 2, it will not give us 0 either. So the rational roots are 1 and negative 1. Now for polynomial equations of the 4th degree, there are at most 4 rational zeros. Meaning to say, it could be 4, it could be 3, it could be 2, it could be 1, or even 0. Now, your turn. Give the probable rational roots of p of x equals 4x cubed minus x squared minus 4x plus 1, then give the rational roots. You can pause the video, and if you are done, I can now show you the answer. So the probable rational roots are 1, negative 1, 1/2, negative 1/2, 1/4, and negative 1/4. And the rational roots are 1, negative 1, and 1/4. Did you get it right? I hope you did. Thanks for watching, guys. This is Teacher Rejil. Keep safe.